So now it's time to welcome Simon from Noveltis for the Qgis presentation. I think there is two parts. The first part dedicated for the beginner people, and on the topic of the Medicanes, so the Mediterranean hurricanes. Simon, are you there with us?
Yes, hi.
Hi, Simon. And then after we will make a short Q&A session, and you will introduce the QGIS tutorial for the advanced people.
Exactly.
On the upwelling. Exact. Okay.
Yes.
The floor is yours.
Okay, thank you. So hello, everyone. So my name is Simon Boitard, and I work as a remote sensing engineer at Noveltis. So today we'll be together for approximately an hour. And the goal is for me to show you the basics of QGIS for ingesting, displaying, and processing Copernicus Marine Service products, and show you some applications that you can achieve in the Mediterranean Sea, and how to use the NetCDF2 GIS plugin. So I'm going to share my screen. So yes, so I'm just going to start with a quick introduction, telling you about the product and the plugin, and then we will start the practical part of this training. So the Mediterranean Sea is an almost enclosed sea bordered by the European continent to the north and the African continent to the south. To the west, it is connected to the Atlantic Ocean by the narrow Strait of Gibraltar. So the Mediterranean Sea represents less than 1% of the world's ocean surface, but it is one of the busiest seas in the world. It carries 20% of the world shipping and welcomes more than 200 million passengers every year. So this concentration of human activities has a great impact on its rich ecosystem. Indeed, the Mediterranean Sea is home to more than 10,000 marine species, 25% of them being native of the area. So this fragile equilibrium is now threatened by the pollution, noise, fishing, and global warming, amongst other factors. On top of that, natural disasters such as Medicanes phenomena are also a danger to the marine wildlife and the human activities in this populated area. For example, the Ianos storm occurred in between southern Italy and western Greece from September 17th to September 18th, 2020. So in this context, the operational, precise, and reliable Copernicus Marine Service products for the Mediterranean Sea are a great asset to analyze and forecast the health of this area. They are also of a great help to monitor and assess the impacts of traumatic meteorological events, such as the Ianos Medicane. So one way of carrying analysis and getting the maximum out of the CMEMS product is to exploit them in a GIS software. So as I was explaining earlier, this short tutorial aims at demonstrating the processing of the Copernicus Marine Service products for the Mediterranean Sea in the QGIS software using the NetCDF2 GIS plugin. So after presenting succinctly the products that we're going to use, I'm going to explain the basics of QGIS and the use of the plugin to conveniently import Copernicus Marine Service products. And then we will analyze the sea wave height induced by the Ianos Medicane, and the sea wave height variable contained in the Copernicus Marine Service products will help us to follow the trajectory of the storm. Eventually, we will check how the wind speed and direction match the areas of maximum wave height. So just in case some of you are not necessarily familiar with GIS, so GIS stands for Geographic Information System, and there are software applications that provide the ability to present and analyze spatial and geographic data, such as digital maps or geolocalized data. So the data provided by the Copernicus Marine Service Portal come in a NetCDF format, which is a common data format that can handle several complex variables. And my colleague Ergan has told you much about that in the Jupyter Notebook presentation. So in order to use these Copernicus Marine Service products, Noveltis has developed a QGIS plugin called NetCDF2GIS, which will enable us to easily deal with NetCDF timeframes and depth levels, and to operate some advanced functions on NetCDF files. So if you are not familiar with this plugin, you will be able to find it at the following address, and there you will be able to download the archive of the plugin and also download the user manual, which is a step-by-step guide on how to set up the plugin in the QGIS environment, and it also gives you some solution on the most common error that you may face during the plugin installation. Okay, so using this plugin in the QGIS software, I'm going to show you how to conveniently ingest various types of Copernicus Marine Service products for the Mediterranean Sea, create maps and animations out of the Copernicus Marine Service variables, analyze the sea wave height induced by the INS Medicane, follow the storm trajectory by spotting the areas of maximum sea wave height, and export this trajectory as a new shapefile layer. And we will also follow the wind strength and direction in the hurricane and check how they match the areas of maximum wave height. And also, I forgot to mention, but if you have any question during this presentation, do not hesitate to ask them on Slido. There will be some time dedicated after the tutorial to reply them, and some extra session later on. Okay, so for this tutorial, we are going to work with two Copernicus Marine Service products. The first one is the Mediterranean Sea Wave Model Reanalysis product. So this product with this identifier. So this product has a spatial resolution of approximately 4 kilometers. It is distributed on an hourly time basis, and we have downloaded the product in between southern Italy and western Greece from September 15th to 20th, 2020. We'll also work with the global satellite wind observation products with this identifier. It has a coarser spatial resolution of 1/4 of a degree. Sorry about that. And we have, it is distributed as 6 hourly mean, and we have downloaded the variables from September 15th at 12 p.m. to September 22nd at 2020 at 12 p.m. So for those of you who are not necessarily familiar with the data download, in the previous session, Ergan showed you various ways of downloading the products, and there are also some former tutorials that are available showing you how to download the product through the subseller. So in our case, we have downloaded both products through the graphical interface. Okay, so now let's move on to the practical part on QGIS. So first thing you need to have on your computer is the QGIS software installed through the OS Geo. And then you need also to have the plugin installed on QGIS. So in order to install this plugin, I showed you the web page earlier. Once the plugin archive is downloaded, you can go to plugins, manage and install plugin, and install from zip. And from there, you can follow the step-by-step PDF tutorial in order to conveniently install the plugin. So once all of these basics requirements are fulfilled, you can create a QGIS project. So project new, here it's already created, and I have called it a QGIS demo. And you need to set a coordinate reference system for your project. So for this tutorial, we will use the classical WGS84 with the EPSG 4326. Okay. Then the main strength of using QGIS is to display the Copernicus Marine Service products in a geographical context. So the first thing you want to do when working with QGIS is to import a convenient background layer. So there are several ways of doing so. Here we're going to...
I'm sorry to interrupt you, Simon, but we can't see the plugin window. I'm not sure if it's on the right screen.
I'm not using the plugin right now.
Okay,
so...
but it's all white. Is it normal?
Yes,
that
yes,
okay?
Yes. Thanks. So the first thing you want to do is to load a map background. So here I'm going to show you one way of loading a map background. So here you can go to layer, add layer, and add a WMS layer. So we are going to load our map background from a WMS server. So here we are going to load it from the map server demo. Here I can show you the detail of the connection. So here I've just given a name to the connection and simply used the following URL to connect to the WMS server. You don't need any account, okay? So here I'm connecting to the WMS layer. And here several layers are available to you. I'm simply going to load the blue marble background layer. So hit add and close. So now you have a nice map background. Today we're interested in the Mediterranean Sea. So let's simply zoom into the Mediterranean basin. It takes some time to load, but then you should have a better resolution over the area. Perfect. Okay, so now that we have set a CRS and a map background, we are going to import the Copernicus Marine Service products in our QGIS project. So to do that, let's hit on the NetCDF2GIS icon. So for now, it's blank. First thing we want to do is to import a product in the NetCDF2GIS plugin. To do so, hit the little plus button over here. And here, of course, it will depend on your working environment and where you have stored your input data. Here, I have stored it in QGIS demo input data. So I'm first going to load the global wind product here, open. And then I can also load the wave product here. I'm going to open that. If you want to open multiple products at a time, you can simply go within input data, select both products, and drag it and drop them to the plugin window. Okay, so once a product is imported within the plugin, you have access on the right panel to several pieces of information on your data. So in the variables tab, you will find information on the name, dimensions, unit, and long name of each variable of your NetCDF product. So here you can see, for example, northward wind, wind speed, eastward wind. You can see the dimensions they depend on and the unit. It's similar to Xarray in Python. Then in the metadata tab, you will find elements on the dimensions of the file. So here 29 timeframes, several latitude and longitude cells. And you will find also global attributes. For example, when the project was created, when it was modified, who's responsible for producing the products, etc. In the option tab, you can choose and set the display prediction of the selected variable and your working directories. And finally, in the About tab, you will find general information about the product itself, the plugin itself. So during the training, we will work with the sea surface wave significant height, and we will also work with the wind speed and the northward wind and eastward wind components. Okay, so let's start working with the sea surface wave significant height. So for our first product exploration, we will display the significant wave height from the Mediterranean Reanalysis model product of the Copernicus Marine Service with a 4-kilometer horizontal resolution on an hourly basis. So here from the variable panel, you can select the sea surface wave significant height, right-click on the variable, and select the sequence layers option. From there, we will only select a subset of the available time frames in our product. So we will have a closer look at the time window defined in between September 17th and September 18th. So we will select the following time frames: September 17th at 6 a.m., September 17th, 12 p.m., 6 p.m., September 18th at 12 a.m., 6 a.m., and 12 p.m. Here, why do we select only one time frame every 6 hours? It's because the wind product that we will use later on as is 6 hourly. So it's to have concomitant time frames in between the wave reanalysis model and the wind speed global products. Once all of your time frames are selected, you can hit the little start button here. And here you can see each time frames displaying one after the other. So here, I'm sorry, I made a little mistakes because the time frame from September 15th is selected. So I'm just going to do it again. Okay, sequence layer. Here I just need to make sure correct time frames are selected. Okay. 6 and 12 and no 15. Okay. Okay, here. And so you can see all individual time frames displaying one after the other. And you can actually already sense how we will be able to follow the Medicaid trajectory based on these values. So once you're done with the animation, you can hit stop and close. Okay. Okay, from there, we can expand a little bit more what's available in each layer. And you can see that the color scale is not really appropriate and does not tell us a lot about the values that we're seeing in our products. So we are going to tune the color scale. For this, right-click on the layer and go to Properties. In Properties, make sure to be in the Symbology tab. There, you'll be able to define the minimum and maximum of your layer. So here, we'll set the minimum of the significant wave height to 0 and the maximum to 4 meters. We'll use the spectral color ramp, but we do not want to have it from red for low values to blue for high values. We want to have it inverted from blue to red. So just hit invert color ramp. In the mode, make sure to select equal interval and define the number of classes to 5 to have one color per meter. Hit apply and OK. So now we have tuned the color scale of a single layer. The other ones are still not perfectly tuned. So what we would like to do is to export the style to the remaining layers. To do that, right-click on the tuned layer, Styles, Copy Styles. And then you can just select the remaining layers and paste the styles. And from there, you can activate and deactivate each layer and again, scroll through each layers. Okay, and each layer have a convenient color scale. Okay, so here you can see that the eye of the hurricane is easily recognizable with low sea wave height values inside the sea wave height maximum area. So these characteristics will help us to spot the IANOS hurricane trajectory in the following part of this training. Okay, so now we are at the core of the QGIS tutorial, which will be to spot the hurricane trajectory based on the sea wave height variable available in the Copernicus Marine Service wave reanalysis product. So during a hurricane, the sea wave height maxima are located on the sides of the eddy, and the eye wall values are lower. So using this information, I'm going to show you a method to create a new shapefile layer where we can add the position of the eye of the hurricane between September 17th and September 18th, 2020. So first, what we need to create is an empty shapefile layer, which will hold the successive position of the hurricane every 6 hours. So here, to do so, we'll go to Layer, Create Layer, New Shapefile Layer. Okay, just going to. So first, we need to define the file name and the directory where we want to store the empty shapefile layer. So for myself, I will store it in a QGIS demo, IANOS path, and define the IANOS path shapefile. Hit save. I will define the geometry type as points. And then if you wish to, at this stage, you can add all the field, which will be the attributes of each of the points you are going to define. So you can do that if when creating your empty shapefile, you already know the attributes you want to set for each entity. For this tutorial, we are going to leave it empty and then create new fields. So we'll leave it empty, and it's always possible then to edit the shapefile and add anything you want. Okay, so we can hit OK. So here the layer already exists, but I'm just going to overwrite it to create an empty shapefile layer. So you can move it up here. So right now it's empty. There's nothing in there. It's just an empty layer that is going to hold our points. Okay, so now it's time to add point features to this new layer. So from there, you can right-click on our empty shapefile layer and toggle the editing mode, or you can simply select the shapefile layer and toggle the editing mode over there. Okay. And then we are going to add point feature here. Okay. Now we are going to scroll over the successive layers and define the position of the eye of the hurricane based on the information available in the Copernicus Marine Service product. So on September 17th, 2020 at 6 a.m., we can spot the eye of the hurricane over here. We are going to set an ID to our point. Here, we are going to start from 0. Hit OK. Then we display the layer the same day at 12 p.m. and set the position. Set the ID to 1, and so on. Set the ID to 2. Three, and 4 here. And then here it's going, oops, it's starting to be harder to spot the eye of the hurricane, as we can sense that he's not fully over the Mediterranean Sea anymore and over part of Greece here, especially on this date. So now we have 5 points defining the successive positions of the hurricane every 6 hours. So you can leave the editing mode and save the changes we have brought to this layer. So now we have a shapefile containing 5 points. What would be convenient as well is to add the dates as an attribute to each point, so that in a single shapefile layer, we have the positions and the date of this position. For that, we'll toggle the editing mode again and open the attribute table. So here you can see our 5 points, and they each have a single attribute, their ID, which is incremented from 0 to 4 by step of 1. So what we are going to do here is to add a new field. We'll name this field dates. So this field will hold the dates of each position. The type will be text. So here there is a date type, but the date type is the precision of this type is limited to days. And here we want to have an hour precision. So we'll set the type to text. Set the length to 16. So it's the length of the field. So the field can have 16 characters maximum. And then OK. Now we are going to edit here the dates field. OK. So to define automatically a field, you can set up an expression here with this button. So from there, I'm going to use the following expression in order to automatically define the date of the positions here. Okay, so be careful when you copy and paste the following expression from the PDF tutorial. You need to replace these little guys here so that it goes well with the QGIS syntax. So what does this expression make here? It works a little bit like what Ergan presented in Python. It's a set of functions that's used to automatize processes in QGIS. So here, with the make datetime function, we set up a start date. Our start date will be September 17th, 2020 at 6 a.m. Okay, which is our first time frame. And then for each point, we'll make an interval, a time interval of 6 hours based on the ID of each point. So for the first point, the ID is set to 0. So the date field will be set to the start date. Then the following point with ID 1, the date will be 6 hours later, etc. So to use functions in QGIS, you can find them there. And here I found my functions in dates and times here. So you have a set of functions already predefined for you. And when you hit on a function, you'll have some documentations, how to use it, the arguments you need to define, and the examples of how to use the function. So here we can simply hit OK and update all. And now by scrolling through the points, you can see that now automatically we have defined the dates of each position. So, okay, so you can leave the editing mode, save the modifications, close the attribute tables. And now we can display our dates as labels to our Shapefile layers. So here you can go to Properties. Taking some time to open. Okay. Go to Labels, Single Labels, set the value to dates. As we want to have the dates really well and clearly displayed on our map, you can draw a background, set it to white, hit Apply and OK. And here you have the various positions of of the hurricane with the associated date. Okay, so now we are done with defining the successive positions of the hurricane using the sea wave height field, the significant wave height, sorry. Can just, okay. So now we are going to play around a little bit with the wind field that's available in the global wind observation products. These products over here. So we can load the wind speed variable here and hit add layers. So now you understand better why we have selected specific time frames in our significant wave height variable, because here we're going to work with the time steps from September 17th at 6 a.m. to September 18th at 12 p.m. Those time frames. You can hit add and close. Okay. So here you can move this up a little bit over here. Okay. As for the wave height, we're going to tune the scale from 1 to 17 meters per second, invert the color ramp, apply OK. Then by scrolling through the individual time frames, one after the other, you can follow the wind speed every 6 hours. And you can already see that it corresponds pretty well to the positions that we have defined using the significant wave height. You can also see, for example, if I focus on the wind speed on the 17th of September 2020 at 12 p.m., that the product resolution is way coarser than the significant wave height. Okay. Okay, and one thing I forgot to do here before scrolling is to copy the style and paste it to the remaining layers. And now you will have a more consistent display here between all layers. Okay. So now one last thing I'm going to show you in the frame of this beginner tutorial is how to display vector field within QGIS using the NetCDF2GIS plugin. So let's go back to the plugin window here on the Wind product. So here we are going to load each component of the wind within QGIS before vectorizing both components. So here, again, right-click on the eastward wind variable, hit Add Layer. Here, as it's just a demo, I'm going to focus on one time frame, but feel free to do it for other time frames as well. On September 17th, 2020 at 12 p.m. You can add and close. Do the same for the northward wind component. Make sure to select the same time frame, otherwise you will not have a consistent wind vector field. So here, September 17th, 12 p.m. Add and close. Okay. Now you can see that both layers have been added to our QGIS project and to the Layers tab of the QGIS plugin. So now you can select both components and hit Vectorize. So here, make sure that the east-west layer corresponds to eastward wind and north-south layer correspond to northward wind. Check one last time that the dates and times are consistent. Set the output directory. Here I'm going to set it here and call it wind vector INOS 17 September 2020 at 12 p.m. Can hit vectorize. Yes, you can hit vectorize and close. One last step. So now you can see that the vectors are conveniently displaying. One last step is to set a proper style. So we'll do it this time by loading a style that is predefined and that you can download with the training kit later on. So here you can go again to Symbology, Style, Load Style, From File, here, Wind Field Style, Open, Load Style, Apply, OK. So now there's a better style with a nice legend in meter per second. Okay, and now if you superimpose this wind vector for September 17th at 12 p.m. and you also superimpose this with the wind speed, so you can see that this is the position that we defined on September 17th at 12 p.m. based on the sea wave height. And this is the wind field. behind that is the wind speed. And if we deactivate the wind speed, you can see the significant wave height field here. Okay, and so you can see that all three variables are very much in line with each other. So we have defined a pretty accurate trajectory of the IANOS Medicaine here. So this was the end of this beginner tutorial on QGIS for the Mediterranean Sea. So just to wrap up this part of the session. So in this training, we used the NetCDF2GIS plugin to handle and visualize Copernicus Marine Service model products and observation products for the Mediterranean Sea. So it enabled us to display the significant wave height variable to define the positions of the Hyannis hurricane between September 17th and 18th, 2020. And then we checked that the position we had previously defined based on the significant wave height were accurate using the wind vector field from the satellite observation data. So this scenarios is workable with other hurricanes in the Mediterranean Sea or other parts of the world. And of course, feel free to visit the Copernicus Marine Service and download other Copernicus Marine Service data to map them on QGIS. So I think I can stop sharing my screen for now and take maybe some questions.
Yes, thank you, Simon. So yes, we have some question for you on your demonstration. I will share my screen now. Okay, do you see my screen and the question?
Yes, I can see that. I can see them.
Okay, so there is a question here. What are the different benefits and disadvantages that characterize QGIS and MyOcean Pro?
Okay, so I would say, but then of course maybe Chloe will be able to add more details later. So I would say that QGIS can be actually used to process the data and to also export the data to various data format. Like, for example, one very nice advantage of QGIS is the ability to manipulate, create, work with shapefiles that are vector layer that can hold several attributes and are very, very convenient to carry out GIS analysis. So really, QGIS is very convenient to is a very convenient software to carry out GIS analysis and create really nice maps.
Yes, you can make computation between the different layers.
Yeah,
you can add different sources of products and data. This is not the case with MyOcean Pro, because MyOcean Pro is just plugged to the Copernicus Marine Service catalog. But if you want to manipulate different data from other sources, I think about EMODNet, for example, with protected marine areas, layers, something like that, you need to use QGIS. So MyOcean Pro is just a tool to discover the data, to start playing with the data, but it's limited, very limited. And if you want to go a step further and try to make some computation between the different layers and add other data, you have to switch on QGIS.
Yes.
Okay, thanks,
Precisely.
Simon. Okay, some people add an error when they try to load the plugin. So I put on the chat, on the discussion, the correct link to download the version, because if you have this,
okay.
I think this is an error due to the version of QGIS.
So either to the version or either from what kind of setup QGIS was installed from, because I can see an OSGeo root issue.
Yes.
So maybe QGIS was installed another way, and that's why the plugin doesn't work at this stage. So maybe I would advise you to try to set up another instance of QGIS on your computer using the OSGeo way, and then try again to set up the NetCDF2 QGIS.
Yes, I put the link on the chat. So this is not a question of version, but just a question of the way you install and the plugin, the QGIS. Okay, thanks. Is it possible to integrate the plugin into a QGIS model to automatize processes and iterate through files folders? Is there any material tutorial on this?
So that's a good question. So I don't think that the plugin can be used automatically. I mean, at least not the graphical interface. Maybe I would suggest, I'm not sure about that, but maybe you can dive into the source code of the plugin, which is, I think, should be available in the archive, and try to adapt that to develop your own routine and your own thing, your own plugin to automatize what the graphical interface of the NetCDF2 QGIS plugin does.
And in general, it's possible to create some macro on QGIS to automatize some.
So I think it's possible. I have never done it myself, but I think if I remember well, I have seen some people doing so before.
Okay.
But then you need to, like, I think, have some knowledge on Python.
Yeah.
So.
Okay. And last question, please, where can I download the shapefiles of the world?
I think that maybe if on Google you type word boundary or shapefile, you should find some material there. Like, on top of my head, I don't have a precise website to recommend, but I'm sure you can find it if you perform some digging in Google. I can look it up later.
Okay, and there is a new question. Okay, how do you save your last plot?
How do I save the last? Sorry. So the last plot. This. I think you can view. You can save. If I am not wrong. So I think that what I do usually is take a screenshot, but I think there are other options available within QGIS where you can actually, like, create map backgrounds, etc. I just don't remember precisely how to do that.
Perhaps we will put the information later on the Q&A file.
Yes.
Okay.
Yes. But the simplest way is to take a screenshot, I would say.
Yeah. Okay. So I take just one or two questions more. When did you select the coordinates of the study area?
So I selected the coordinates of the study area when I downloaded the products, so that it was already subsetted to a convenient area. But in the advanced scenario, we also show you a way of subsetting the coordinates, the area of interest directly on the QGIS.
So this is on the second tutorial on QGIS, available soon with a video tutorial through the Padlet. And is it to have a video format output from QGIS?
So I'm not sure about that. I don't think so. But what you can do is, again, take a video screenshot to export the animation conveniently.
Okay. But we can make animation on QGIS?
So we can display animations, as I showed during the tutorial, thanks to the plugin.
Yeah.
But I'm not sure there are a predefined functionality within QGIS to actually export directly in, for example, MP4 or MKV or such format.
Okay, I think we're going to stop now. Again, all the questions will be answered on the Q&A document, and you will access all the answer later, soon after the webinar.